warahmatullahi wabarakatuh and salam sejahtera. Today we will continue our topic in improving performance of Rankine cycle. This is the component that involved in Rankine cycle. We have pump, boiler, turbine and condenser. And also we learned from our last lecture that the thermal efficiency is given as W net over Q in. So what is W net? W net is work of turbine minus work of compressor, and it is divided by Q in at the boiler. Q in is heat addition. Okay, so how to improve the thermal efficiency? The idea is the average fluid temperature should be as high as possible during heat addition in a boiler, and the average fluid temperature should be as low as possible during heat rejection at the condenser. First, we go to the superheating the steam to high temperature, which means we increase the average temperature. Okay, if we can see at this TS diagram, okay, we will superheat the superheated steam to high temperature. Okay, and what is the effect of doing this? We can see, okay, before we heat the steam, the turbine work of turbine given as H3 minus H4. Okay, after we superheat the steam to higher temperature, we can see that the new WT is H3 prime minus H4 prime. Okay, so we can see that this new work of turbine is greater than the initial work of turbine. So the work net will increase. So since work net is increased, the thermal efficiency will also increase. And we can see here that the temperature or the Q in, okay, the heat input is also increased. Before this, the Q in is H3 minus H2. After we superheat the steam to the higher temperature, we can see that the Q in is H3 prime minus H2. So the effect of superheating the steam to high temperature is it will increase the network, okay, because the work of turbine is increased, and also it will increase the heat input. Therefore, the thermal efficiency will increase, and if we can see here, the moisture, okay, content of the steam at the turbine will decrease from here to here. Okay. Next, to improve performance is we increase the boiler pressure. So this is the initial pressure of a boiler, 2 to 3. But if we increase the boiler temperature, the boiler pressure from here to here, we can see at the color area, this is the increasing in W net. Okay, if we increase the W net, if we increase the operating pressure of a boiler pressure, it will automatically increase the average temperature, okay, of the steam at which boiling take place. Okay, so what is the advantage of increasing the boiling pressure? We can see here that it will increase the W net, and we can see that the moisture content of a steam at turbine is also increased, that it will move from right to left. Okay, but this will but this problem can be corrected by reheating the steam, and we will learn about this in our next topic. Okay, so since the W net is increased, okay, W net is increased, therefore we can say that increasing the boiler pressure will increase the thermal efficiency. Okay, next is lowering the condenser pressure. This is the initial condensing pressure, and this is the new condensing pressure. So the color of this area represent increase in W net. Okay, so steam exists as a saturated mixture in a condenser at saturation temperature corresponding to the pressure inside the condenser. Therefore, lowering the operating pressure of condenser will automatically lowering the temperature of a steam that fulfill this requirement. Okay, that's all for topics of improving performance of Rankine cycle. Thank you.